Alright, Max hits the ball from the edge of this cliff here. He hits it at an angle of 30 degrees with an initial speed of 60 to the horizon as shown. And then the ball follows this projectile motion here. We know this is a projectile question. The first question asked us, how high above the top of the cliff does the ball rise? So how high does it rise up here? Because this is a projectile question and he hits it at an angle, what we can end up doing is separating this into vector components. This is the important thing we need to do first. So he hits it with 60 meters per second, but we can say this is made up of a speed going that way and a speed going that way. This is 30 degrees. We just use a bit of sine cos tan and we get the speed going this way is x speed and this is the y speed, and the formulas are for the x that'll be 60 times cos 30. I'll just show you how I got that, but this will be something you end up having on your cheat sheet. 60 here, 30 degrees, and this is the adjacent, and this is the hypotenuse. So that's katoa, so it's cos. So cos 30 equals adjacent over hypotenuse. We want to find the adjacent, so we've got to times both sides by hypotenuse. Hypotenuse times cos 30 equals adjacent, and the hypotenuse is equal to 60. 60 times cos 30 equals the adjacent. That's what I've got, 60 times cos 30. You do a similar triangle for the y, the vertical direction. You get uy, so initial speed in the y, 60 times sine 30. Okay, so the reason I split this up, it's like having, if I hit a ball this direction, it's like hitting two balls, one with an initial velocity going that way, and another with an initial velocity going this way. This one will get to the same height as this, and this one will get to the same distance as this. Right, but we want to know the height, how high above it, so we only have to work with this guy here. At the moment, we only have to work with the vertical component. So what does that equal? 60 times cos times sine 30 equals, sine 30 is 0.5, so 0.5 times 60 is 30 meters a second. So its initial speed in the vertical is 30 meters a second. And we want to know how high it goes. So it's like just saying a ball going up and then coming down. How high does it go? We want to know x. We know, we'll start with its initial is 30. When a ball goes up and comes down again, its speed at the top is equal to 0. And its acceleration, if it's heading up to start with and it's being slowed down, the acceleration is downwards. So that means it's negative 10. And then we can put all of this into an equation of motion. The one that has them all is v squared equals u squared plus 2ax. So that's 0 equals 30 squared plus 2 times negative 10 times x. I'm going to minus 30 squared from both sides, and 30 squared in my calculator is 900. So minus 900 equals minus 20x, that's an x. And divide both sides by minus 20, you get 45 equals x. So that there is 45 meters high. Alright, here's the same picture again. Max hits the ball, yada yada yada. It now takes 9 seconds from here all the way to the bottom. What's the height of the cliff? H. Alright, so there's a number of ways of doing this. I'm going to do it 2 different ways to show you we get the same answer. Yeah, I'll do these two different ways, and let's start with way 1. So we know that's its initial speed there, but we know its initial speed in the vertical direction we've already worked out in the previous question was 30. That's going to be helpful. Alright, so we know u equals 30 upwards, we know a equals negative 10 downwards, they've given us time equals 9 seconds, and we want to find out x equals question mark. So what have we got? We've got the equation of motion is x equals ut plus half at squared. So that equals 30 times 9 plus a half times negative 10 times 9 squared. That equals 270 plus negative 5 times 81. And you do that on your calculator, you get negative 135 meters. What the heck does that mean? How can you have a negative distance? And what it means is, it means that we chose our initial speed, well, the initial speed's going up, and we said that was positive. And we said acceleration, which was going down, is negative. So anything up is positive, anything down is negative. And what have we got? We've got a negative 135. That means the distance from the start is 135 down. So on this diagram, it means from the start here, the distance that goes in the vertical is 135 down. And that's our height. 135 meters, okay? That is way 1. Way 2. It's going to take a little bit longer way 2, but it's just another way of looking at it. What I want to do is, I know it takes 9 seconds. I want to find out what time does it take to the top. So I know that we've got u equals 30, we've got t equals question mark, v at the top is 0, and a equals negative 10 because it's downwards. What we've got with this one, we've got v equals u plus at, so we've got 0 equals 30 plus negative 10 times t, minus 30 on both sides, we get this, and we solve, we get t equals 3 seconds. So to the top, t equals 3 seconds. That means if it takes a total of 6 seconds to the bottom, t equals 6 seconds. And I'm going to do an equation of motion, same thing with that. So from the top, we know the initial speed is 0. So the new initial speed from the top is 0. We know time is 6 seconds. We know acceleration, because we don't have to worry about any positives, one's going up, one's going down. At the moment, everything's going in the downwards direction. We're just going to call that positive. 10 and x equals question mark. Alright, an equation of motion with these in it. X equals ut plus half at squared. X equals 0 times 6 plus a half times 10 times 6 squared equals 180 meters. So that means from the top here to the bottom is 180 meters. But we've already in the last question worked out that this distance is from here. It's meant to be a straight line from the top of the cliff to the top of the ball throw. We've already worked out as 45 meters. So 180 minus 45 equals 135 meters. So the answer, there should be a box there, 135 meters. You can choose which way you want to do it. I'm sure there's other ways as well, but those are just two ways of looking at the same problem.